Hello everyone, my name is Matt Rule and today I'm going to be talking about a solar energy STEM activity that I conducted. First, my overarching project that I do with my 7th grade tech ed class is I actually have my students build small solar powered cars. Excuse me. And we typically race them outside using the natural sunlight to give them the best understanding of how solar energy works. And that is obviously weather depending. And determining colors and ideal race location would be a great addition to this project, I think. Here's just a quick video. This race was done inside due to uncooperative weather conditions outside, but just to give you an idea of what I have my students doing.
On your mark, get set, go! Oh! Jack still claims.
Okay, so there you got to see a little bit of my students racing their solar powered cars. I'm going to go through the engineering design process, and this is also a little bit of what I do with my students as well. And this is the flow chart for that process. And I'm going to kind of walk through each step as we progress through the presentation, explaining what I did for each of those steps in that process. So the first, step one, is identifying the problem. So I kind of have three problems that I came up with for this activity. How can we as a class identify the ideal location for our solar racetrack? How can we determine optimal sun exposure? And does color play a part in sun absorption? So those are the three questions that we'll kind of be thinking and looking at as we progress through this activity. Step two is to explore. I know we were given all the same jumping off point as Dr. Dietrich said, but so for this I'm going to be using a bottle and balloon as a homemade thermometer to help me judge the different locations. But you can do research for this on bottle sizes, whether that has an impact, balloon color, whether dark or light balloons would affect the outcome, as well as paint color, etc. So on to step three, which is the designing phase. I knew that it was important to maintain the same variables for both thermometers, therefore I used 32-ounce Powerade bottles for both, so maintaining the same bottle size. I used the same balloon size for both, and I also used the same balloon color for both, because as I said before, potentially if you used a darker color balloon compared to a lighter color balloon, that could affect the time that it takes to inflate. Excuse me. And I only used white and black spray paint to have a maximum difference in color. Step four is to actually create them. Here's a quick picture of what the final product looked like, but to walk you through a little bit about that process, to start, you're going to need to have the materials for your thermometers, which were 2 bottles, spray paint, which was black and white in my case, balloons, a timer, as well as newspaper. So the first thing you do, obviously go outside, you're using spray paint, and just lay the newspaper down, put the bottles on top, and then you can spray each of the bottles, whatever color you choose to make them, and then obviously let the paint dry. After that is when you get to attach the balloons to the top of them once the paint has completely dried, and there's a final picture of what those homemade thermometers look like. Step 5 is to try it out. I decided to test both bottles at the same time and time how long it took the first balloon to fully inflate. Since my students would be determining the optimal racetrack location to test our solar powered cars, I decided to test 3 different locations and compare inflation times to determine which location had the greatest sun exposure, because with us racing our solar powered cars, it's important to have the maximum amount of sun exposure to allow the cars to work the best that they can. So by comparing those different times would allow us to see which had the greatest sun exposure, as well as, since we're testing them all at the same time, determining which color works best. So my location number one for my first test was on my porch. I compared both, and it took 58 seconds for the black bottle to fully inflate. My second location was on the driveway. This one was much longer, and it took about 1 minute and 57 seconds. But once again, the black bottle balloon inflated first. And the third location was on the sidewalk. This was much more comparable to the first, with an inflation time of 1 minute and 3 seconds. So the results from the test, as you could see, the black bottle inflated first in all locations, showing that the darker the color of the bottle, the quicker it will heat up and absorb more sunlight. And the order of the locations from fastest to slowest were the porch with 58 seconds, the sidewalk with just over a minute, and the driveway with almost 2 minutes. Step 6 in the process is how you could potentially make it better. And the things that I came up with, excuse me, would be I would have each student have their own bottle and choose the color that they were thinking about painting their solar-powered car. They would then paint their bottle that color, and we would all test our bottles at each location and see, one, which color works the fastest, as well as comparing times between the several different locations that we would test in order to figure out where would be the best location for our racetrack. In terms of the chart for the STEM practices found in the reading by Vasquez, as you can see, this activity really incorporates a lot of the different components of science in terms of asking those questions and developing models and carrying out that investigation to actually see which location would work best. In terms of engineering, we actually created our own homemade thermometers, so actually building and engineering those as well as testing them. Technology, we use the different components of the thermometers as well as the timing materials to actually time how long it took each balloon to inflate, and also mathematics in terms of timing, and then calculating the difference between those times to see which one is the fastest and what the difference was, in once again determining that optimal location. So as you can see, this activity really covers a vast majority of the 4 disciplines that go into STEM, and that is my activity and what it would then lead into, and I want to thank you for listening to my presentation.